Question 1. The 16th percentile of a normally distributed variable has a value of 25, and the 97.5th percentile has a value of 40. Which of the following is the best estimate of the mean and standard deviation of the variable? Okay, so the 16th percentile and the 97.5th percentile are not just some random percentiles that they've chosen. In fact, they actually correspond to one of these 7 boundary values given to us by the 68, 95, and 99.7 rule. Okay, so let me explain a little bit more. We know that 68% of the data falls within one standard deviation, okay? Which means there's another 32% that needs to fit somewhere in this curve, okay? 32 divided by 2 is 16, right? So 16% of the data are below the z-score -1, and 16% of the data are above the z-score +1, right? That gives a total of 100%, okay? So the 16th percentile is going to be this location right here, and they're saying that that has a value of 25. Okay, so let's go ahead and fill that in, 25. Okay, the 97.5 percentile, well, we know that if we go 2 standard deviations out, that's going to capture about 95% of the data. Now everything has to add up to 100%, so there's still 5% missing. Okay, if you split that 5% in 2, you get 2.5% there and 2.5% there. If you combine those two regions together, you get 97.5%. So this value right here is the 97.5 percentile, which according to the description would be the value 40. So this value here is 40. Okay, so now with those two values, we should be able to figure out the rest of the boundary values here. I can see that 25 to 40 is a difference of 15, but that's 3 different regions, so 15 divided by 3 is 5. So that means that should be 30, that should be 35, that's going to be 45, 20, and 15. All right. So the distribution we're looking at is approximately normal in shape, has a mean of 30, and it has a standard deviation of 5. So that means our answer is going to be choice E.